What's up, guys? In this video we're going to be going over analog, and it is a subtractive synthesizer for Ableton. So we have our MIDI track open, we have it selected, we're going to double click on analog, and here she is. I'm going to open a signal analyzer, two of them. You can get it at rsmet.com, or .com. I'm going to have one set to signal and the other set to spectrum. So what I'm going to do, just for the ease of use, is I'm going to just don't mind this for now. Alright, so I have a sine wave, and this should sound familiar to you. This is the basis of synthesis, right? And it's very simple. It's just a sine wave, and this is what we were modulating stuff with before, but now it's in the audible range. This is a shape. See its shape right there, and this is an oscillator, and it is a cycle per second sound generation, and the area from here to here, the shape is the duty cycle, and depending on the shortness or longness of the duty cycle is the pitch that we're getting, and it's done with math and voltage. So a shorter duty cycle is a higher pitch. Alright, so we have that sine wave, which is the basic shape of everything. We have a saw, right? Same type of deal, duty cycle, We have a square, and this is our square wave. And we have noise, which is all frequencies at once, and it's just random noise. Okay, so we're gonna go with our saw wave here. We have our selection. So how it works is you program synths left to right, okay? And usually synths will have, you'll have how many oscillators? 2, 3, 1, a noise generator. You'll have a filter, 2 filters, and then you'll have your amplifier section, and then your modulation section, and then your volume, and whatever else, right? So how it works, how analog works, is we have our oscillator 1, which is a simple, just a sound generator. That's all it is, and it takes receiving notes and plays them out depending on what pitch you're playing. What note you're playing depends on what pitch you're playing. And then that goes into a filter, and you click on these to get a sensitive kind of menu in this black area here, right? We have our filter, and what that does is it's the same thing as like the filters you're looking at before, the EQ, and you have a frequency and a resonance, and that shapes the sound. That's why you get the term subtractive synthesis. You have your resolution here, or your resonance, right? Different cutoff, different resonance, right? And then you get to your amplifier section, which is volume, but it's attached to an envelope, right? So we have our envelope down here, and we can shape it. There's this is an ADSR, so it's attack, decay, sustain, and release. So we can have a slow attack by moving it, or moving this, so the amplitude gradually goes up like this, instead of being instantaneous. We can have it slower. That's fun. We can drag the sustain down, so there's more of a clickiness. So we can bring the volume up that way, and there's that. We can have the release time, so when you let go of the note, the sound will gradually fade out. So you have a slow attack and a slow release. Pad from when dinosaurs roamed the earth. Alright, we have that. And then it goes into the volume and then out. We have a modulation section which modulates a bunch of stuff. And there's that. Alright, so we're going to kind of go back. Alright, we have our generator here. This little box is one of our first generators. We have another generator, and we can turn it on and off. We have a second oscillator. One thing I should explain is you have your kind of transport controls here. We have octave, so you can go an octave up. So if you're playing C, you you can go an octave up. You can hit the same note, but then it goes an octave up to the C note up. Right, up or down. So you can do neat things with that. You have your semitones. So if you have 12 steps, 12 semitones up, you're up an octave, right? It's the same thing. So you can do kind of neat stuff with that. And detune is a fine detune. It's in between +3 or -3 tones. And that'll kind of emulate, analog drift, which is a different story. You have your volume of your oscillator, the oscillator volume, which is like a pre-amplifier section. So you can drive the filter. And we'll get into what that means later. We have filter routing. So you can go all the way filter 1, all the way filter 2, or like a 50-50 split, right? So you can have oscillator 1 going into filter 1 and filter 2 respectively. Right? So we have that. We can drive the filter, get a more aggressive sound, and it's really sensitive to what kind of filter you have going on here. All right, what else here? Yeah, we have a pitch envelope. So it's kind of like an ADSR, but it's different. It changes things over time. It's a pitch end time. So it's only like an attack and decay, and you can do neat things with pitch. Oh, might want to turn the filter up. All right, we'll go back to that. Right, so the pitch is up and then it goes down, right? Or we can have it elongated or really fast, like a kick. Right, and there's that for our pitch, and we can right click and send things back. We can have this modulated. All right, I'm going to show you what the LFOs do. So over here we have our modulation section. This is LFO 1 and LFO 2, right? And we have same thing as the modulation section of this course. We can have different kinds of waves modulating different things. Retrigger means, I'll show you what retrigger means later. Okay, so we're gonna have our oscillator here, and we're gonna have. We'll notice that when we turn the LFO, low frequency oscillator, on, this menu lights up. So we are modulating the pitch of our oscillator 1, right? We can have it go up or down. So that's basically how it works. We have our speed there. What retrigger means is the phase will restart every time you hit a key. So right now I'm just pressing keys. Right? If we have the retrigger on, it restarts. And you can get some really interesting sounds that way. And it's really neat. You can also sync the LFO to the host BPM. And you can do like a triangle type thing or a noise, which is a randomized value over a stepped period of time. Okay, we got that. I'm going to show you a context menu for the square wave. We can change the width of that pulse. So we can have it a perfectly symmetrical square wave. And then we can change it to a very fine pulse, right? And that's reminiscent of like the old Juno type of sounds. And we can modulate that with an LFO. So we'll grab our LFO there. We'll go back to here. We'll reset the pitch. We don't want that, but we want to modulate the pulse width. And we can kind of tone that down a little bit. What the heck is going on here? Oh. There we go. So we have our LFO modulating the pulse width. And that would create like oldie 80s pad sounds. And there's that. Let me drop in a new one here. All right. So this is the default sound that'll be dropped in. Right? We will go to our amplifier and we want that to be sustained and released so it sounds proper. All right, we have that. We also have a noise generator. We can just have that going. There's no other options for the noise generator. It's just a simple noise generator with a filter in it and a volume, right? So it's pretty neat to mix in white noise to make something sound a bit more dirtier. So knows what it's doing. Instead of having like a pure clean tone, we can dirty it up with a bit of noise. And that really adds to like that analog sound that people get really excited over. Yeah, okay, we're gonna get into our filters here. All right, we have different options for filters. You remember how there's poles and then dB per octave, right? So a higher pole and higher dB per octave is a higher cut on the filter. So I will open this analyzer so we can see what's going on. So we have that, and then 12 dB will be a bit more aggressive. We have our band pass. Oh, my apologies. This is also a way to get an interesting kind of oscillator shape. Band pass. We have our notch, which kind of carves in a particular area. You already know this. We can modulate that with the LFO to create like a phasing effect. I'll just kind of show you now. Where are we? Oh yeah. Right? You know, just simple stuff. We have format, and format is like it's a shift of the frequency, and it is kind of complicated to explain. Yeah, it shifts the cutoff frequency a certain amount up, and it's a format filter. You hear this in dubstep a lot, and it's kind of like our mouths change shape when we talk, and our tongue and all that gross stuff. It's basically we're creating upper harmonics with filters through speaking, and that's what the format filter does. It's just another flavor of your filter. So another thing we can do with our low pass, we can have this, but what I want to do is I want to have the filter open and close as I play the notes, and I could do that with an LFO, so it'll wobble. Which, yeah, I might as well just show you that right now. Right, we have some wobbly bits here. I'll turn up the level on the amplifier. I can adjust the speed. So you can do dubstep at home now. So let me know how that works out for you. But this also has an ADSR or an envelope, and what we can do with that is have the envelope amount. I believe this is it. Right? So we have the filter fully open. We have the envelope at max at 8. Right? We can adjust the decay. We can have it not so intense. Right? So what it's doing is the filter is open fully, and then as the note, goes along its path of whatever it does, the filter closes automatically. Right, and you can do some really interesting things with that. All these are kind of case sensitive. All right, I'm going to go over filter drive. So what this does is, you know how we have the output of the output of our oscillator past 0 dB, it's into 9.5. We have the ability to have drive, so we can have it off, and we'll boost the resonance just so you can hear it. we'll have a drive. So we have a symmetrical 2, asymmetrical, different. Yeah, that one's a bit more aggressive, and they're different drive forms. So what would happen is you would have on like the old Moog synths, you'd have basically the headphone output, and you'd put that into the back, into the external input. So you'd have the filter being driven by the filter, and you get like this really neat overdriven sound. And you get really intense sounds, as opposed to, it's just different flavors. This kind of saturation or drive is kind of unpredictable, but it works. You can turn filters off and on. And that we're clipping hard here, but it's just for funsies. Alright, I'm gonna be back and we're gonna be going over some more stuff, and yeah, we'll be back.